Just going to start off with, this is my first conference talk. It's not my first talk, but it's the first one to this many people. And I'm also the guardian of lunch, so no pressure, none at all. So with that, my name is Rory Hardy. I work at Cerner. I'm a software engineer, and I work on a team that is building the face of web applications for healthcare. And as a part of that, we're tying engineering to UX. It's really cool. If you want to talk to me about that, talk to me afterwards, because it's not my talk. I'm talking about closures and currying in JavaScript. But before we can get into that, we should really have an introduction to functions. And just to be clear, this talk is an introduction to the concepts. It's not a down the rabbit hole kind of conversation. So just that heads up. So your basic function that doesn't do anything. It's just a function. It takes any arguments. It does absolutely nothing. If you looked at libraries, you might know it as noop or no operation. You give it whatever you want. Doesn't matter. It returns undefined. It does absolutely nothing. But functions aren't that simple. You got to take it a step further and look at another one, the identity function. So what's beneficial here is it's taking in a variable. Now, JavaScript has two kinds of variables that can get passed into a function. It can have value types, which means they are effectively recreated internally and bound within the scope of that function. And then you have reference types, which means that it's not a new version, it's the same one that was being passed in previously. So to distinguish that, anything that is an object is a reference type. Everything else isn't. A thing to note on that that's important later is that functions are objects, and therefore are a reference type. So to look at this function, you can give it a string that says cat, and it'll return a string that says cat. But it's a new string. It's not the one that's passed in directly. Whereas with the object, it's the same object. If I manipulate it somewhere outside of my object prior to returning, it'll reflect whatever those manipulations were. And functions can evaluate to functions. That's totally reasonable. Functions are objects. They're first-class citizens in JavaScript, which means that they can be taken as arguments, be returned, doesn't matter. So, we have a function here that is so it's a function that evaluates to a function, which then subsequently evaluates to true. So just a quick overview with functions. Let's move on to closures. So part of my motivation for giving this talk is I'm constantly asked, what are closures? I've read about them, I've heard about them, or I found this article that's just multiple pages, I don't want to read it. Too long, didn't read. So that's one side. So another thing I do at Cerner is I mentor new hirees, and I teach a JavaScript class to help people who are unfamiliar with the language get up to speed quickly. And closures are always a little bit of a pain point. So, if you're coming from C or Java, that may not be necessarily familiar to you. And in a lot of academia, that's what you work with is, C, Java, PHP, whatever, at least that's what I got. So it's kind of my motivation. So really, it's just a concept of scope. In JavaScript, you have function scope. When you create a new function, there is a new scope created for that function. Anything outside of that function knows nothing about it. It's invisible. You can kind of think of this like a box inside of a box. And I was working on making a cool visual for this, and I'm not a good artist, so I don't have a visual for this. But the point here is, the stuff outside can't see it. Obviously, the contents inside the function can, and this can be nested. And so basically, at the top level, you have global. Everything sees it, and it goes down from there. 2 seconds, I'm going to make this thing stop trying to dim the screen. So, okay, cool. So it's just utilizing scope to do things. And in a function, and I go out of my scope, grab something, and I use it. Well, okay, that's all it is. But why do I care? Well, they give you a way to associate data with a method. And for a hint, I'm talking about private variables in a global world. Which follows up with my next bullet point. And, okay, so who here is familiar with the module pattern? A few of you? Does not work without closures. Not going to work. I'll link you guys to the slides a little bit later, and I linked out to what the module pattern is for those who aren't familiar. It's a very, very popular development paradigm in JavaScript. Also, so who uses jQuery? Or has used jQuery? All over the place in there. You just got to look for them. And in so many other libraries. They just exist for a variety of reasons, but they're everywhere. So let's look at a really simple example. We have an outer function foo with an inner function bar. Foo takes in a variable, and whatever that value is bound to x. And bar likewise does the same thing, and it's bound to y. So we call foo with 2, and foo creates a new function bar, and then it invokes bar, and it also happens to pass it 2 for easy maths, and then we console.log the result of x plus y. We get 4, and that is a closure. Now, we don't retain anything. It's not a particularly useful closure, but it is a closure because the inner function is accessing the variable that is bound to the outer function's scope. Bar has no x inside of it. That's what makes it. And of course, that brings up the question, if I'm returning a function, do I have a closure? Well, no, we can have a function that returns a function that evaluates to true. And that inner function doesn't have to touch the bound variables. It can. If it does, it's a closure. If it doesn't, it's not. So in this case, we do not have a closure, but we are returning a function from a function. So the guys over at jQuery made basically a set of articles where you can learn about JavaScript. It's learn.jquery.com, JavaScript 101. And they have probably my favorite example of a closure in action. It's simple, and it just really works. And this is it. Pretty much copy pasta. So here we have a loop with an iterator variable where we maintain the increments as we go through our loop. And for each step along that loop, we call timeout and we pass it a function. And we will, after some set amount of time, print out the result of the I value with a delay. Great, should work fine. But the result you're going to get is 5 repeated. And the reason why is that loop is going to finish its execution and set your value of I to 5 prior to any of your delayed timeout calls. So you can create a function that takes in that I value and then returns a function that utilizes that I value. And by separating that out, and we talked about value types versus reference types, because this is a number is not an object and is therefore not a reference type. So when I pass 0, 1, 2, 3, 4 to each subsequent call, it's bound internally to that function. And as long as it is referenceable, it is going to stay there. And it's going to stay in memory, which comes to a quick side note. JavaScript is a garbage collected language. The short version of how that works is if I can reference it, don't delete it. There are of course some rules and roundabouts for that, but that's the short and sweet. If it's there and it's referenceable by something, keep it because you might need it down the road. So if we use, oh, that's overlaying my modifier there. So if we use another function that takes that in and then binds it and then persists it, we have here, we will get 0, 1, 2, 3, 4 as expected from taking this process. So we still have the loop, we still use set timeout, and we still pass set timeout a function. The difference being that we have an intermediary function to effectively cache or memoize that value, and then it just returns the function, which is then executed by set timeout. So that's kind of just seeing where it just makes that, it keeps that data associated to what you're doing and creates that nice data association. So obviously, private variables are a nice thing to have. Or being able to persist variables is a nice thing to have. So let's just say, for argument's sake, we're going to pull an 80 megabyte JSON string from a service via AJAX. It could be nearly instantaneous. It could take a half an hour. You don't know because you have to deal with network latency. But you also want this to be private. So oftentimes what I see is there's a function, and it goes out and it gets its data, and it does something with that data, and then it returns. And then that data goes poof because it's garbage collected. Then the function's called again. Now it has to go make that request again, and your app quickly gets sluggish. But you don't have to do that. You can take advantage of Clojure to just sidestep that. So in the below example, we have a variable which is the result of this whole function call, which means bar will reflect the returned function is what's going on. So we go and grab our big giant data set, whatever it is, it comes back, we set it to our hidden variable, whatever we want to call it, and then we return a function that does something to it. Accesses it, mutates it, whatever. Or a set. You can return an object with functions bound to them, however you want to do it. But now, because I've done that, that inner function that's been returned references that variable. And because it is referenceable, and it references the variable, that variable must persist in memory in order for it to continue functioning properly. And by doing that, you have just created private variables in JavaScript with really very little work. And the module pattern kind of takes advantage of this. This is like a really, 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 really slimmed down version. And like you couldn't really even call it the same thing, but it's kind of the same idea. So that's Clojures. So let's talk about currying, and I know it's before lunch, so I couldn't resist throwing up something I made a few days ago, maybe to get you guys hungry for lunch. It's maybe good, maybe bad, I don't know. But cool, so I'm not even gonna read this. That's the Wikipedia definition. Really, currying is just taking a function with multiple arguments and turning it into the same or a similar version of that function with less arguments. Kind of sounds like there might be closures involved in that to memoize however many variables you want to stop having to pass. And yeah, it builds on top of that. So why do I care? You can make higher order factories, more on that in a little bit. You can avoid continuously passing the same variables. Let's say I have, just for argument's sake, I have a function add. It takes two parameters, x and y. But really I need an add 10. And it just needs to take one argument. So I'm always calling add 10, or add with 10 is my first parameter over and over and over and over again. Well, I can curry add, memoize the first value is 10, and then I have an add 10 function, and I don't have to care about it anymore. Simple, but that's kind of the idea. And you can also handle state dependency in functions this way as well, and a little bit more on that in just a bit. So code. Well, give you half the code. So pretend that we have a method, and we're going to call it curry, and it transforms any function into a curried version of itself. Sorry, not built in, but plenty of resources out there with these done and built for you. So we have a function. It takes two parameters, kind of like add, but in this case, it's meant to print out a message for you. And so at the bottom there, we print out the result of saying goodbye and Sarah Connor, and we get the string goodbye Sarah Connor. But we want a hello version, and we don't want to say hello over and over and over again because that's we want a hello function, just that's what we want. We don't want to deal with it. So you curry it, basically memorize hello is the first parameter, and don't ask the users for it anymore. That's pretty much it in a nutshell. And so like I said, I teach a JavaScript class, and a lot of times when I start talking about these functional concepts, I get a little pushback, and there's some frustration. And my typical response to that is, so a lot of you raised your hands saying you guys use jQuery. Has anybody used array map? Anyone in here? All right, so cool. Well, guess what? You've already been doing this. Array.map, well, what does it do? It takes an array and it applies a function to every single value in that array, and then it returns a new array, which is the result of applying that function to all of them. Functional programming. For the jQuery users, if you want to hide all the things, some selector, each function, hopefully you're not doing that just to fade out, you're doing some other stuff with it, but the point is you're applying a function to each element in your selection. And this is functional programming. That's what you're doing. You're already doing it. You just might not see it, and that's okay. So I mentioned that you can do state. This is a really slimmed down example. So let's say I have a function, and it needs, depending on state, it needs to do different things. Maybe this is a click function. Maybe in some situations I want to turn a background red, or I want to turn a background green, or whatever, depending on some set of rules. So you could have, if it's this, then do that. If it's this, then do that, littered throughout your code. Or you can create a function that updates whatever function you want to use so that it matches your rules at a given set of whatever given time it is. So here we have 3 states. We have a default state, we have a specific state, and then we have a, well, I don't want it to do anything right now state. So you just say foo is equal to set foo, or whatever you want to call it. You set a parameter, and it's going to do that operation for you. Now you might be going, wait, but I thought this was currying. Well, it is. You'll notice that I'm not calling foo with any state, with any argument. Set foo starts with an argument, which is state, and I'm memorizing that effectively and transforming the function to suit my needs. So it's technically currying. Some might argue that it's not, and that's fine. But it's making a simple function I can use throughout my code base that does what I need, and as long as I update it as needed, where I need to, that's all I got to do. It's really simple. So, okay. So higher order functions. It's going to build off the previous 2 concepts. A higher order function basically needs to do one of 2 things. It needs to take one or more functions as an input, or it needs to output a function. Now, that's a pretty simplistic definition. There's some cool stuff you can do with that. And I want to take a look at that. So I use D3.js a lot. And I was making a componentized library with it. And I got really tired of writing getter-setter methods for changing things like width, height, color, whatever else. Because I had to write them for every component over and over again, and it was just tons of boilerplate code. And I just decided I didn't want to do it anymore. So let's take a look at that. So we have a function. It takes 2 parameters, and it returns a function. That function takes 1 argument, kind of sounds like currying, and it also does some memorization, kind of sounds like using closure. And so you're taking those two ideas and merging them together to create something new. And what we do is we define some visual component. This one's just a little rectangle, nothing special. And you define some options that you want to be able to change with it. So in our case, we have width, height, and color. And we have opinionated that to 200 pixels wide, 50 pixels tall, and it being black. But obviously, someone consuming our component may have different opinions about that. They may want to change it. And, well, I could write a function to handle all of that, which is the inner function is the boilerplate of what that looks like. And I have to repeat this per variable, which is kind of gross. So alternatively, I can just loop over however many options I have and generate them on the fly. So that enables me to come down here and say, cool, I want my color to be green, and it's green. Just right there. No getter setters have been hard-coded by me, the developer. So what's nice about that is it can give consistency in your application. It's really easy to start copying and pasting really boilerplate code like that, and then start changing it just ever so slightly, and then introducing bugs just because of the nature of changing it in that way. So this avoids it, but there is, of course, a caveat. It comes with a trade. This uses up memory and resources, way more than me just typing it out. So I kind of live in the ECMAScript 5 world, and from what I understand, with ECMAScript 6, and of course, now that I'm saying this, it's not going to happen, and I'll be wrong, but it's supposed to have a method missing type of system built in. So if I call for a function and it doesn't exist, it's going to defer to that before it throws an error. If true, you can extend this concept to be a factory. And what I mean by that is, instead of me building all of these getter setters up front, well, maybe the user only wants to change the color. They like my opinions otherwise. Do they need the methods defined? Probably not. They're just going to change the color and they're happy. They don't necessarily need to know if it's getting instantiated on the fly and then invoked for them, as long as the end result's the same and it's not bad performance. So that's kind of the quick overview, run over with closures and currying and how you can tie them together to make new ideas and new things. So, cool. Well, I want more. I want to learn more. So, again, I'm going to give you guys a link for this in just a minute, but these are some choices I would give to you. JavaScript Allonge is an awesome book. What I like about it the most is that the author doesn't make opinions about what you do or don't know. And he takes you through all of it. I mean, the basics all the way to combinatorial mathematics in JavaScript. I mean, it's all of it. And it's just written in such a way that it should be tangible to anyone and everyone. I highly recommend reading it. The Mozilla Developer Network, they've got resources for everything. Seriously, you want to learn more about closures? Check out their page. It's great. I've already mentioned learn.jquery.com, and it's another great resource. So then, I'm trying to remember which ones these are. So JavaScript is Sexy has Understand JavaScript Closures with Ease. It's a really nice article, and it just goes in all the ins and outs of how they work, how to use them, and how to use them effectively. Partial application in JavaScript. I mentioned that currying is not a built-in thing, but there's resources. That page has both the simple version, which just cuts down one variable at a time. You have to keep currying to yield a result. And they also have an example of how you might be able to put in placeholders by passing undefined to fill in those gaps, which is also really cool. And then, of course, you can't leave out Douglas Crockford. He's got a really great article on curried JavaScript functions. I highly suggest that as well. So hopefully these will be useful to you. Slides are available at slides.com/Rory Hardy. Feel free to go there, download them, take a look at them. So that's pretty much all I have. I blew through that way faster than I meant to, probably because I didn't have a water bottle. So that means we have lots of time for questions. So. Yes, it's a complete book. And no, the book is called JavaScript Allonge. If you just do a search for it, you'll find it. There's a lot of ways you can access it. You can read it for free online, or of course you can purchase it via multiple different media to do that. Yep. And sorry, I meant to repeat his question. The question was the first bullet point, JavaScript Allonge, is that a book? And yes, that is a book.
It's a good resource for examining function context and how it gets dynamically reassigned.
Can you speak up? I'm sorry.
What's a good resource that exemplifies function context prototyping that you're dynamically jumping into that objects, doing event calling, that kind of stuff?
I don't know of a good resource offhand, but I'd be happy to help you find one afterwards.
A lot of topics address it as a matter of fact, or they give a couple of examples. But then as you go through the rigor of writing code, I find myself, how do I exemplify this? My model, my own understanding.
Okay. I'd be happy to help you look for that a little bit later.
Have you considered an alternative approach to currying implementations where you decorate functions with metadata instead of using closures? I was wondering, I didn't think about it. I was thinking maybe like it'd be better for debugging and memory to just returning a function, but put properties on functions, right? So you can stick the amount of arguments left and the argument gated on that function every step of the way. Do you have any thoughts about that, or have you seen anything like that?
I want to say that. Oh, thank you. Sorry. So the question was about utilizing function decorators as opposed to necessarily using closures and currying. And I haven't really experimented with that myself, but I want to say that that is at least briefly covered in the JavaScript Allonge book. So I know he at least gets into function decorators. So that might be a resource for that. Any other questions? All right, well, thank you for your time.